Hi everyone, thank you for attending and welcome to this session, Solves for Ansible at SUSECON 19. My name is Pablo Suarez Hernandez. I'm a senior software engineer at SUSE, working as part of the SUSE manager team and also part of the so-called Solve Squad. So let's start asking you some questions like how many of you have used Ansible before? Quite a lot. Okay, and how many of you have heard that Ansible is actually easier to start with than Salt? Okay, a few. Exactly. Have you tried to migrate a customer from Ansible to Salt? Okay. Okay, so during this session, I will try to show you how Salt is competing with Ansible and how SUSE is committed with Salt and is actually contributing to Salt to make it even better and even more salty. Okay, so we are SUSE, as you know. Yeah, we have been doing enterprise now for more than 25 years. We are literally making airplanes to fly in Germany, of course with zero downtime. Why are we talking here about Sol? Sol has become and is now integrating a few of our SUSE enterprise products, for example, SUSE Manager, and it's now a core component, and that means that we support it. We support Sol, and we are deeply involved on Sol development. Oops, sorry. And why do you want Sol? As I told you, we are making it even better. We are committed to improve it as much as possible, and we would like you to also play with it as we are doing. So I'm summarizing here a few of the main features that are coming from SUSE are included in this next Sol release called Fluorine. These are a few of the things that we have improved and we have worked on this Sol release. The first is, well, we have invested a lot of time and work on the Sol SSH. We now support targeting a system that has different Python version, which was not possible before. So if you have a Sol master with Python 3, you can target and work with SSH minions that has, for example, Python 2.7. Well, apart from that, another contribution we did around Sol SSH is that in order to play with Sol SSH, you need what it's called a roster file, where you define your host and so on. It was needed to create that file before and then start playing with Sol SSH. But now you can simply do Sol SSH IP and your Sol module. It will ask for the authentication. You provide authentication, and it will automatically generate your roster file for you. Okay? That makes Sol SSH really easy to start playing with. You don't need anything. You don't need to install anything. You just need Python on your target machine, and that's it. Another feature is the minion master auto discovery. So in case that your network security allows that, you can easily deploy new minions without actually set any configuration. So we implement the auto-discovery, master auto-discovery mechanism, so the minion will directly search for the master, and it will authenticate against that Sol master. Sol-based Superconfig. We usually have to deal with bugs report from customers. And when they report a bug, we ask them to provide also what we call the support config, which is basically a tarball where we collect log files, hardware information, packages that are installed on that system, and all this kind of information that then is sent to us and help us a lot for troubleshooting and debugging the issue. what we have done here is that we recreated that component inside of Sol. We are going to do some demo later, but it will basically allows you to define some kind of profile, your own. Well, we provide some default profiles, but you can define your own profiles where you collect whatever information you actually want, and you collect that just defining an SLS file, a YAML file, where, not SLS, a YAML file, sorry, where you said, okay, I want to call, to execute this particular Sol command, for example, package list package to list all the packages I have installed. I want to collect this and that. And then you just run Sol support, and it will collect, execute all those modules, all those calls, and it will create that tarball for you directly. And well, another thing is Sol Capabilities is under development, but the first step are already there. Basically, I will explain it later, but the idea of this is a mechanism that will allow to know if a particular minion has or not some specific capability. I will explain later because it's not enough for checking, for example, the Sol version to know that. We need to go deeper. We have sometimes backported patches or PTF, stuff that brings some capabilities inside the whatever Sol package version, and we need a way to know if that particular minion with that particular Sol version has or not this capability. Then another feature that we integrated is that now we are allowed to define environment variables to be used for individual functions or individual modules instead of having somehow a global environment for the whole Sol. We can isolate and define environment variables for those particular Sol function or modules. And last but not least, Ansible Playbook integration. So now we have introduced, we will do a demo later, and tomorrow there is going to be a specific talk about this. It's called How to Smoothly Migrate from Ansible to Salt. And we will be basically playing around this new module, which is called Ansible Gate. And it will allow you basically run Ansible from within Salt. Okay, so we want you to also take part. Well, we have promoted the RSC process on Salt. So now the new features idea are starting with an RFC upstream, where the community is allowed to take part in the design discussion of the upcoming features that are going to be designed and implemented. We are actually actively reviewing the Sol upstream pull request, and we are very close to the development team of SaltStack, so we share the roadmaps and so on. So we actually invite you as well to take part on the community, make PRs, review, and help us with that. So, okay, now I'm going to go across a few of the main selling points that Ansible has. Let's just take a look. So the first thing they said, or one of the things they said is, okay, Ansible is agentless. It's agentless for immutable servers. Okay, it's agentless. It's agentless, but it's also clueless. So it's a clueless system that works like POP3 email system, where where it is totally silent unless you explicitly kick it to talk, right? So you can run some monitoring stuff and integrate it back to trigger Ansible stuff, but then it's not a longer simple stuff. You need to start putting stuff on top to get into some type of behavior, like that triggers something that basically allows you to get something from the Ansible client, right? For the managed client. Keeping the analogy, it's like if we are running POP3 versus IMAP, right? So if POP3 is still around, but if you are in a lifetime from the 20th century, then it's okay, but as long as you are dealing with a smartphone and all this kind of stuff, then POP3 is not for you either. So you need to start using something more sophisticated here. On Ansible, you don't have, you have no agent, but you have also no clue what's going on there. You have to somehow call a fetch mail to see what's going on there. Ansible also talk about this concept of immutable infrastructure, where you basically you spin up some instance, and in case that you need to do some changes on that, then you have the idea is that you don't make changes directly on that instance, but instead you spin up a new instance where you put those changes there, you test it and so on, and once it's green, you basically replace the old instance with the new one. That's okay. But this immutable concept is kind of, say strange. I mean, because actually those instances are not really immutable. So, for example, databases are still writing. The storage is still storing and growing. There are security patches that you need actually to apply. Customer data is still mutable, so they are not actually perfect system. So you need, so every mutable stuff needs some configuration management, and configuration management can also construct your baseline for images and then manage the life cycles of them. So you can do also this kind of immutable management using configuration management for building your baselines and also for managing the life cycles of them. Okay, another selling point, grid security. Okay, SSH is just fantastic, right? Well, unless you find some bug. Also, the SSH has some, you have these problems with when you're trying to scale because of the TCP connections. You have also the problematic of the key management. So there are some risks on the key management, key tracking troubles, key rotations, key sharing or replication. So, well, of course we love security, but all software can be broken. And SSH can be broken too. Easy and simple. Okay, they say so. Do you remember that? It was actually easy and simple to start with. But we all did that on the past, because it was very sweet, it was very easy to start, but then what happened next? If you try to scale to billions of users, what happened? Then you will need to do something like Facebook did, like converting PHP in C++ and something, because if not, your game is over. So the question here is, why not to start it right from the beginning? What happens if you make it raw? And you have something that doesn't work. So SSH simply does not scale. We have also this Galaxy, Ansible.com, which is basically like a collection of modules that are submitted from random user, well, from the community, right? It looks good, actually, but question is who controls the quality of those modules? Can you guarantee that this code is actually audited? If this is audited, where to store those audited versions and prevent from people from altering them when you are actually installing those modules on your system. In our case, since we are using RPM package, we have a RPM signed packages, checksums, and so on. So we can always check the integrity, right, from those modules that we are installing in our systems. So now we are going to talk a bit about not the difference that Salt has with Ansible, but how Salt improve those problems that we have been talking. So Ansible might be different and maybe is even more convenient in at some points on some environment, but it's not necessarily overall better, especially on the long run. Okay, Salt is battery include. So we don't like Perl for not being battery include. We don't like Ruby poor quality gens. We actually love Python that comes with many default modules with excellent quality. Salt tries to resemble this culture. So if you have a bug or a feature, you just submit a PR upstream to the main Salt project, and that will be reviewed by the community, well, but the Salt community, and it will get eventually merged if everything goes fine, and it will be part then of the Salt code base. If you have an RPM, which is vendor supported, then all those changes that are new, you will get them, and you can verify it consistency. So there is no problem. If you start installing live random module, you don't know actually who takes the responsibility of that code. And we are talking here about serious enterprise. Okay. Another thing is that Salt has full awareness of events. So how exactly Ansible is going to report the status of the machine if it's not even there unless you specifically ask for do so. So on Salt, we can handle all kind of events from all over the places, and that those events are not let's say monitoring event like, okay, flags like true, false, and so on. They can be as complex as you want. You can fire event from different sites. You can fire your custom event if you want and include all the information that you want. Salt is also covers from Nano to Epic, right? So unless you are really, really that small, your infrastructure is going to grow anyway. You want it or not. So your customer data is going to grow, your configuration files are going to differ, et cetera, et cetera. So Salt is actually ready for configuring complex cluster and ecosystem. And here this pull method and the event bus wins. It's really, Salt is, plain Salt Open is really ready for handling large amount of system in heterogeneous environments, nodes that have a lot of changes and so on. And it's ready for doing complex orchestration with clusters and very complex infrastructure. So we have not only a solution that works for us more or less medium or small, medium size, but we have something that it will scale to the space. Okay. Remember the hammer from before, right? Okay, but there is something called Ansible Tower, right? Yeah, there is, and it makes a lot of sense, and it gives Ansible a lot of features that the plain Ansible doesn't have. But this is now a completely different product. This is no more, well, this is now open. And basically, yeah, we are talking about a completely different stuff. So this is no longer simple. You need to install then also a few components in order to make the Ansible Tower to work. You need PostgreSQL, OpenShift, and so on. A few different stuff that makes this no longer simpler. And it reminds a bit to this Puppet ecosystem where you have the Puppet server for managing the Java, which is written in Java and has a lot of components that you need to put together, and so on and so on. Okay, so what's the future here? So as I told you at the beginning, we are committed to keep contributing to SALT in order to make it easier to start working with, like with our improvement in SALT SSH or the auto-discovery mechanism for minions. We want to make it even more consistent, even faster, as I told you at the beginning, even more salty. So let's take a look at this. Now I will go by just doing some explanation of these, let's say, coolest features that we have bring into the SALT. So the first one is the SALT Superconfig. I explained it at the beginning. So basically, this is the tool that we have. Well, we have the tool on SUSE, which is the Superconfig for collecting all this kind of information for troubleshooting. We have reassembled this on SALT. Troubleshooting helpers. So basically, we can collect whatever we need. We can create our own custom profiles. Of course, submission of new profiles are very welcome. You can just create PRs to upstream, and they will get in. And as I told you, they are basically YAML files, that allows you also have some Jinja on it, and it basically will generate or will execute in order to collect all this information and produce the tarball that we want to provide. And a good thing is also that apart from writing your own base modules, you can not only gather information from SALT itself, but you can gather whatever information that you have on your system where you are running this SALT support. So let's go with a demo of how this SALT support is working. Let's see how can I switch to this. I want reference, monitor adjustments. Terminal line. I want to see it here. Maybe I should increase the fonts a bit. Okay, it's readable, right? Okay, so I have here just a simple environment with only one minion. And let's switch to the minion here. And as I told you, we have now this command line tool, which is called SALT support. If we run it, you will see that it will have more or less the same options that a normal SALT command line tool has, and like the logs and so on. So the first thing that we can do here is see the available units. So this is a minion, and SALT support said that the available units here is a minion, which is okay. And we can look at the profiles available here. As I told you, we have some default profiles that we provide, but you can just create your own YAML file and execute that one. So let's try then to execute the default profile. I run and so unit minion profile default -F to override any existing file. So you run it, and it will start executing, collecting status, hardware, well, all the tasks that are defined on this profile. It is collecting possible upgrades. I'm not sure if Zipper is going to fail now. I'm not sure if yeah, it should fail now since I don't have the internet here, or maybe it's. It's not here. Let's see if it finished. But I can run another one, a different one. I have some, no. Let me run a different one. Well, okay, I can select the upgrade. It continues with the next task. And at the end, I get eventually this tarball, which I have here. Let's just go here, 19. And I have all those files created. For example, let's take a look at the configuration. It has here the configuration of the minions, all the ops. I have general health, boot times, information about the partitions, and so on. And all kind of upgrades should not be, it's not collected because of the issue. Repositories, all the repositories that are set for this particular minion. So at the end, I have a tarball, which I can just provide and attach to the bug report, and it will help us a lot to troubleshooting. And this is, as I told you, just here included. Let's take a look at one profile. Let's see if I have something. It's on user B, user B. These are one of the provided by SUSE. This increase support profiles. For example, this default profile we just executed is this. So it's a YAML file. We have this sysinfo description, and this is what we want to execute: grains items, package, description, list of package. It's basically calling the PKG list packages, and so on and so on. So we define what we want to do, and we just call the source support to execute all this batch of tasks. So for example, let's just, in case that you have here some custom profile, you can simply source support minus u minimum minus p my default, and it's now executing that one instead of the ones that are on the system. Okay? Good. Let's switch back to the presentation. Sorry, to the I think it was like this. Yeah, sure.
Is there any plan to integrate this with the spacewalk debug?
That's more or less the idea. So first we have now the tool for doing that, and it might be also because one of the cool things is that it's really easy to define very specific data that we want to collect there in defining some kind of profile. So it's actually better when we want to, we can just tell a customer, okay, put this YAML file and execute the source support and bring it back, bring us back the result from that. We don't have to make some changes on the spacewalk debug. Okay. Let's go back here. Okay, continue then. SOL capabilities. SOL capabilities are really, really handy for an enterprise environment. How to know if a particular minion has or not some feature available. We cannot, as I told you, we cannot trust the SOL version because, for example, we create PTF, which are patched to the package that we provide to the customer for fixing some kind of issue. And that is not altering, for example, the SOL version you have. It's just putting some patches on top. So we cannot actually trust the SOL version in order to know if a certain feature is there or not. We also do backporting of functionality on legacy system. So how to know actually if a particular code is there on this minion or not, and we can execute something or not. That's where SUSE capabilities help us. So in our SLS files, we can do something like, for example, this. So we can check is host is actually a parameter from the network ping module. And then do something. It's not, we do whatever workaround of that. Or we can check, for example, if the zipper info installed function has a parameter in the documentation that contains this, and then we are sure that this particular minion has this feature or not, and we can then act and have our SLS files that are able to, so we have a single SLS file that is able to handle minions that are not up to date with minions that are really updated and has the latest functionality and so on and so on. Okay, so SolWinds, no. So did you make actually the choice to move from Ansible to SUSE? Do you have a system that you actually want to move to SUSE? How to start actually moving from Ansible to SUSE? There is an answer, which is Ansible Gate. As I told you, there is going to be a session tomorrow at Belmont 1 at, I think it's 11 a.m. in the morning. And this session will be just focused on this. I'm going to do a demo now, but if you are interested in this, I will invite you to attend tomorrow because we are doing much more stuff with the Ansible Gate tomorrow. And we can run playbooks since Fluorine. So this module, what it basically allows you is that it will enable you to execute Ansible module using SUSE. And not only that, but it also allows you to run the playbook that you already have and run it from SUSE. So you can actually start putting SUSE on top of what, for example, a customer that you want to start migrating, or you want to the customer start playing with SUSE, you can start doing stuff on top of what the customer already have. You don't need to tell them, okay, you need to remake everything that you already did. You have your playbooks that are already audited and so on. And now you are telling the customer that they want to, they have to get rid of everything and they have to remake everything on SUSE. No, that's not the way. So what we want to do with this is that enable the customer to start putting some SUSE and playing with SUSE, but on top of what they already have, and reusing what they already have from within SUSE. Okay, let's run a demo about this. You don't see this. I have to switch again the monitor. Sorry about that. Predetermined applicator. Okay. So again, I'm on the same environment. So the first thing, well, the first thing you need is you need to have Ansible installed on your minion. Okay? So this is our, let's say that our minion is our Ansible controller. Then I can just, from the master, start doing something like Ansible.list. These are all the modules that Ansible provides. You can do help. You will see the help from this particular Ansible module. I can actually look for the options of this module. So this module accepts a parameter called data. And of course, I can execute that one. So we have here, we made a call to the minion to actually execute the Ansible system ping module on that minion, and we pass this hello from Salt, and we get this response through the Salt event bus, but this is the response from the Ansible execution, and we get it on the Salt. We can go a bit further here, and I have here some test Ansible SLS file, which is a state. I call it my Ansible state, which basically calls system ping, right? And I can do then a salt state apply test Ansible. You have it. So this is a Ansible module that has been executed during a state application of Salt for a minion. And the last fancy stuff, I have a different environment here, where it is here for tomorrow. Okay. This is a different environment here, but, well, let me look at this just to see it. This is a playbook. Oy, sorry. Up. This is a playbook, very simple one, where I'm just targeting all the SUSECON hosts I have defined on my Ansible inventory. And I said, well, these are actually, I'm just doing some demos, so these are basically CentOS, are not sleeve. And I'm basically installing HTTPD. Well, I'm setting that the HTTPD state should be present. So this is pure Ansible. There is no Salt there. Okay, and I wanted to basically tell this guy to run this playbook. Okay? And let's see what happened. Ooh, we have here some output. Okay, we have in a Salt way, we have all the Ansible facts that we have always at the beginning, and then here, okay. Here is the actual response. So from this one, SUSECON CentOS 7 changes false because it was already installed. You see the raw information, the results from the execution saying that this package was already installed, and so on and so on. You have this summary here at the end. As you see, I have two hosts. One is Sleep15 and this is CentOS. Since our playbook says that the OS family should be Red Hat, then this is only applied here, but it's skipped from this Sleep15. Okay? So here we trigger the execution of a playbook, which was done on Ansible, and we apply that playbook from Salt. Of course, that means that we could even react to those events when those events get into the Salt. And I can trigger reactions of those Ansible playbooks executions depending on the state of the execution, which is something that Ansible doesn't do by itself. Okay? So this is a really powerful new tool that is coming from SUSE to Salt. And yeah, if you want to know more, please attend to tomorrow's session, because we are doing much more stuff there, and we will explain like how to smoothly migrate, what will be the steps for introducing Salt into a customer infrastructure which is pure Ansible, how we can actually help the customer to migrate and start using Salt. Okay, so let's move again. No more. Esta es a la izquierda. Okay, it's here. Escape. Okay. Oh, this, sorry, I put in this bit. Demo. Okay. So next step. No more installed Ansible on Aluminium. We are thinking on in a similar way of how SSH, salt SSH is working. So when you are working with salt SSH, your systems, your managed system have no salt minion installed. You basically create an SSH connection there. And this salt SSH, what it does basically is it creates somehow some tarball, which is with all the salt code base, and it's transferred there to the target system in order to execute whatever module or whatever task that needs to be executed there. So we are thinking about something like that in a way that we can actually also provide the Ansible module that we want to execute when we are making the call, to avoid having to have the whole Ansible installed on that menu. These are ideas for the future. And also to be able to run non-Python module. So, which is something that Ansible is also able to do. So here we are dealing with Python, but the idea is that we could also execute external modules that are not even in Python with this interface that Ansible provides. So yeah, that's more or less what I wanted to show you today. So as I told you, we are really committed to Salt. We are very actively developing Salt, and we are taking part of, and we are very close to the Salt upstream team. We share our roadmaps. Yeah, so if you have not chosen yet which solutions, if Ansible Salt, or if you already did, but yeah, you want to also see how you can migrate system or customer that are already running Ansible. So I hope that this session gives you some ideas. Yeah, I hope you have learned something today. So that will be it. Thank you very much. If you have some question, I'm welcome to answer you. Thank you very much.